Good afternoon to all my dear students. So first we will revise the topic. It is a summary of the previous class. Last class we discussed about the measurement of level. Here level means it is nothing but it is the position uh, or maybe the height from the datum or the reference line or the baseline. So that is nothing but uh, level. And then this level refers to the quantity of the liquid also. Quantity, maybe the level, and we can get, for example, length, breadth, and height of that particular volume. We can go for, we can go also calculate the quantity, right? And then next, after that, we discussed about the two sensors, that is a capacitive level measurement sensor and ultrasonic level indicator. In this capacitive, here the two plates which are parallel, here we are dipping into the vessel whose containing in the level containing liquid whose level has to be measured, right? In this two capacitors, here the two capacitors are fixed. And here all of you know that the capacitance formula is epsilon naught r, epsilon r a by d or t, as our consideration, as per our consideration. Here a is nothing but area, cross sectional area or overlapping area, and next d is nothing but distances between the two plates. Here, these are distance between the two plates, whatever the two plates of the capacitors, we are dipping into the liquid containing in a vessel whose level has to be measured. Then here, the distance is maintaining constant and the area is also constant. There is no movement. But here, the liquid level changes. Whenever the liquid level changes, maybe rise or drop down, this indicates in between the two capacitor plates, the medium is changing, that is the dielectric. Here, the medium between the two plates is changing, thereby the capacitance also changes. So that capacitance calibrated in terms of the level of the liquid in the vessel or in a container. So that is the process of capacitance. And in ultrasonic level indicator, in the ultrasonic level indicator, here we are, that source, the main source is ultrasonic sound waves is transmitting. And then that is, it is, that means focusing on the surface of the liquid, and then thereby it reflects, the sound waves reflects when it strikes on the surface of the liquid layer, and then automatically the a receiver is there, receiver, it receives that signals, ultrasonic sound wave signals. So here the time period, that means here we are placing a transmitter and a receiver on the top of the vessel containing liquid whose level has to be measured. So here what happens means when the ultrasonic sound wave sends, it will strikes on the surface, and then the sound waves received by a receiver. Here receives sound, transmitter, receiver is there, and then vessel. So here received, and the time period, here the time period, that means transmitting to receiving the time period. With the help of that time period, we are calibrating the level of the liquid in the container or a vessel. So if the time period increases, means the level of the liquid is very less. The time period is very less, means then automatically the height of the liquid in the vessel is more. So because the time period reduces when the level is increasing, then automatically the time period is reducing. When the level decreasing, automatically, that means here the ultrasonic wave strikes on the layer of the surface of the or surface of the liquid, then it received by a receiver, then it will takes time. So if it is level of the liquid is very less, then if the level of the liquid is at high means, then automatically the time period received by a receiver is less. Thereby, this time period we are calibrating in terms of the level of the level of the liquid in a tank or in a vessel or in a container. Then today we are going to discussing about here after completion of this class, we can get a knowledge on magnetic cryogenic, that is magnetic indicator level indicator, cryogenic fuel level indicator, and bubbler level indicator. So now we'll discuss these three. It will take around 5 to 10 minutes only, each and every one. So first we'll discuss about the bubbler level. If you go through this bubbler level, uh, so, so 1 minute. Right. In this bubbler level, if you observe clearly in this bubbler level, here a bubbler tube is there. Bubbler tube. Here in this is a bubbler tube, and this is bubbler tube. Right. This is the bubbler tube. It consists of a bubbler tube and air flow meter and a pressure regulator. And here one side of the bubbler tube, here this is complete from here to here. This is a bubbler tube. So here one end we are sending compressed air, and the other end of the bubbler tube is dipped into the vessel containing liquid whose level has to be measured. So here in this, for example, if you observe clearly, here another one pressure gauge is arranged at the top at here. That means at the bubbler tube, we are arranging a pressure gauge. We are arranging a pressure gauge. See here, same here. These two figures are same. There is no difference. So here, when the compressed air sends with the help of the pressure regulator by regulating the pressure of the air, then with the help of the air flow meter by we are sending that compressed air into the uh, container through the bubbler tube. That means here the dipped end right here. If you are seeing clearly, this is a dipped end. One end is dipped into the vessel. Here, when the air sends into the bubbler tube through the uh, pressure regulator, then automatically whatever the pressure of the air must be equal to the here pressure of must be equal to the pressure of the liquid at the bottom of the tank. Means the pressure having air, right? This air having a pressure. So when sends that compressed air at the dip end, almost all some bubbles will become, right? These are the bubbles, right? So when the bubbles will come, that means what indication is that the pressure of air is equal to the pressure of the liquid in the bottom of the tank. So that is nothing but hydrostatic pressure, which is observed in the pressure gauge, that pressure. So that pressure is calibrated in terms of the level of a liquid in a tank. That is actual procedure. That means the hydrostatic pressure of a liquid, which is proportional to the liquid level, which is proportional to the liquid level. So again, I'm repeating, all of you listen carefully. Here it consists of a bubbler tube and airflow meter, pressure regulator. Here one side of this one we are arranging or we are supplying a compressed air into the bubbler tube. That means bubbler tube through the pressure regulator, and the other end that is here this is nothing but the dipped end. Here the one end of the bubbler tube is dipped into the vessel containing liquid whose level has to be measured, and on the here one pressure gauge is arranged on the bubbler tube. So here when the compressed air sends into the bubbler tube through the pressure regulator, then automatically at the dipped end, if you get the bubbles, these are, see, if you see, these are the small bubbles, then it indicates, see here we have to regulate the pressure. Here we have to regulate the pressure of the air such that here the air bubbles will come. This is the air bubbles. These are the air bubbles. So once the air bubbles is come in, so then it indicates the pressure of the air is equal to the pressure of the liquid at the bottom. This that is the hydrostatic pressure of a liquid, which is indicated on this pressure gauge. That is nothing but is that pressure is proportional to the level of the liquid in the tank, right? You clearly understand, right? Right. P is equal to QH, right? Right. RP is equal to mgh. mgh. Of course, here what you said, P is equal to QH. One person returned that 39 lateral entry. Lateral entry 39, Sunil. Lateral entry 39, respond. Okay, okay. Here you write P is equal to QH. What is Q? Okay, this is the explanation, complete explanation. After completion of this one, I will post in the right WhatsApp group. This is complete explanation of the right. Next, magnetic level indicators. See here in these magnetic level indicators. Here, the very less attendees are there. Better inform to your friends. Right. Right. Here in this, if you observe this magnetic, especially these magnetic level indicators, is used for toxic liquids. Toxic means poisonous. Toxic means poisonous. These are used especially for where we are. It's very difficult to measure the level of the liquid. That means corrosive, toxic and corrosive liquids. Right? Maybe the temperature is very high. At that situation, also we can go for these magnetic level indicators. Here, if you observe clearly, here it consists of in this figure, all of you see here. Here it consists of a float. This is a float. See here, if you observe clearly, here this is a float. See here, this is a float. This is a float. So here also, if you observe clearly, this is a float, right? And in the float, a magnet is arranged at the mid here. If you arrange it, here a magnet is arranged. This is a magnet. This is a magnet is arranged, right? Here, this one, this float and the magnet arrangement. Here you have to place into the a liquid containing in a chamber, closed chamber, whose level has to be measured. Then automatically here what happens means here in this around the chamber, here we are going for a magnetic shielding device. Here if you observe clearly, it is a this is this is completely, it is a magnetic shielding device, right? And and the other end, some indicator here, this completely on a sealed chamber, this magnetic shielding device in one side completely, and here another, if you observe clearly, at here, this is indicator, that is wafers, small wafers. These are diamond shape. These diamond shapes are the right. These diamond shape of the small wafers are arranged in a series. So here, once here the level of the liquid rises up and down, thereby automatically these wafers will undergo a blinking. For example, if the level rises, then the color appears in the on the wafers is Um, one, for example, if it is one direction, then it is a black, and for the movement of the float in one direction and the yellow surface, that means yellow, that means a black and yellow surface. That means here the float is revolving on the level of the liquid. See here, for example, if it revolves in one direction clockwise, then the wafers appear in black, and another direction the wafers appear in a yellow color. See here, these again I'm repeating, all of you listen carefully. This is used especially where the liquids, that means toxic and corrosive liquids, so very poisonous, maybe at hot temperatures. Here in this, it consists of a float which is placed in the vessel containing liquid whose level has to be measured. Then in the float, a magnetic bar is there. This is a magnetic bar, and around this sealed chamber, there is a magnetic shielding device, and there is an indicator. In this indicator, wafers. These are the wafers. These are the wafers. See here, these are the wafers are arranged in a series. Here, when the float, for example, when the level increases, the float will move, where maybe rotate. So here in the rotation, what happens means the color of the wafers will be changed. For example, if the level of the liquid is at here, only these two wafers will glow. So up to this only the wafers will glow. For example, if the level of the liquid is at here, the level of the liquid is at here, then up to this only, these wafers only will glow. So that indicates the level of the liquid in the tank. So I will show one YouTube video, then you can clearly understand it. Just I will show you that video. See here, this is nothing but what I said, that a black colored surface, and when it is rotate in the opposite direction, there will be a yellow color also, yellow color. That means yellow and black both. Here the wafers are coated with a luminous paint and rotate 180. The wafers will rotate. That means it glows. When the level increases, automatically it glows. The wafers are arranged in series and attached in the sealed chamber, right? Okay, right. I will show one video, then you can understand clearly. This is the explanation of that one. Okay, right. I will show you, all of you see. Then you can understand. Very good. Very well. So 1 minute. I will share that one. All of you see now. For all of you, it is visible. The screen is visible, Amma. Screen is visible or not? Anybody? Screen is visible or not? Screen. I'm asking about screen. Okay, 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 okay. Okay. Just I will play. You can watch that one, so that this magnetic level indicator, you can get some knowledge on this video. See here, if you observe, 1 minute. Here, see in this, these are the wafers. See here, in for example, in some magnetic level gauge, the wafers should be different. Here, what we seen in that, it is a diamond shape, but here it is rectangle, right? So 1 minute. right? Correct. So here, see, this is the vapor. So when the level increases, see here automatically this will also increases here. There may be a scale is there, right? Of it. See here, this red. See here, this red indicates this is a float. This is the float. This float will rise up when the liquid level in the sealed chamber. See here, this is liquid level. If you observe, I will go for annotation. See here, this is a liquid level. See here, this is a chamber. This is completely a chamber. See here, the shape of the chamber. This is the shape of the chamber. If you observe clearly, this is the chamber shape. This is a big one, chamber shape example. So here, this is nothing but a liquid level. This is a liquid level. Observe clearly, right? Right. See here the level is rising. See here when observe. Again, I'm repeating. All of you listen. See carefully. See here. This is liquid level is at here. At here. See here. It is dropping down. The liquid level is dropping down. And here this is the float. And here wafers increasing automatically. See here, if you observe herely, the material is non-corrosive. Whatever you are using that magnetic level indicator. For a corrosive liquid, so we can go for measuring. So because why? Because it is a non-corrosive. The whatever the magnetic material that like that float and all the things. But here in our it is only 180-degree only rotation. Here in this magnetic 360-degree. But here what we discussed earlier, it is only 180-degree only. Here the float. Say these are the float. This is the all of you see here. This is one type of float. What we discussed in the now previously what we discussed in the figure. And these are this is also float should be in this shape and this shape. These are the various shapes, right? And this float, the material is a non-corrosive. Remember why? Because we are measuring for the level of the liquid in the corrosive, right? Corrosive liquids. Actually, these are the arrangements. For the what I said, the protection is entirely it is a magnetic shield, right? So these are the just arrangements for that magnetic float. So for that, they around the sealed chamber. We have to arrange the sealed chamber. Okay, right. So okay, right. Now I will stop it. So 1 minute, Amma. 305, it is visible. Now it is screen is visible. Screen is visible. No. So now the screen is visible. Okay, 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 right. So now we'll discuss this cryogenic fuel level indicators. Here, this is a very small explanation for this cryogenic. Here, the cryogenic, it is nothing but it at low temperatures only. See here, it's low temperatures only. That means here the gas, it changes from the gaseous liquid to the liquid state, gaseous state to the liquid state, right? So these are called where that is occur only at low temperatures only. That is we can also call that as a cryogenic fluid. Cryogenic fluid. Here, if you observe it here clearly, a superconductor wire. Here a superconductor wire. Here see a superconductor wire is placed into the fuel which is at a very low temperature. We have to dip into that, and then and this superconductor wire will touch us at the bottom of the tank, and then whose level has to be measured. This is a cryogenic fluid which is at low temperatures. I think anybody knows about the cryogenic. Can you go for that? Some words about cryogenic. Anybody? Anybody? Cryogenic. Anybody? Cryogenics. Cryogenic. So whatever you know, just express it. Maybe two or three words. Cryogenic. Here, the cryogenic means this is the fluid exits in a liquid state at a very low temperatures. That means the temperature at which the superconductor shows zero resistance characteristics. That means cryogenics. If you observe, the cryogenics always maybe sometimes below 0 degrees centigrade level. We can also call it as it's a cryogenic level, cryogenic area. That means cryogenic temperature. So that is at low temperatures. What happens means, for example, a gaseous state, gas in a gaseous state. That means gaseous state will be converted into a liquid state. So for that, we can measure the level of that fuel, which is in the form of a liquid. All of you know that when the temperature increases for a particular liquid fuel, then what happens means it converts into gaseous, right? Am I right? So here that what we are doing this cryogenic fuel level indicator means whatever the fuel is in a gaseous state, that one we are converting into a liquid state by lowering the temperature. So here the temperature is lowered means automatically the phase changes. Fuel level is in gaseous state, it will be converted into a liquid state. Maybe if the temperature increases, then automatically what happens means that fuel will be converted into again into gaseous. So, liquid state, or somebody said that liquid state. Yes, it is in a liquid. Cryogenic fluid is in a liquid state. Yes, nitrogen. Right, very good, very good. Liquid nitrogen. Right. Ravi Teja number lateral entry to 12. Right. And see here, this mainly, all of you listen here, just only two sentences, we can close the class. Here, simply what we have to understand, when this superconductor wire, we have to insert into the fuel in a tank whose level has to be measured. See, that superconductor wire should be touched at the bottom, and the fuel, this cryogenic fluid, it will be, that means Fluid is nothing but it is either in the form of a liquid or a gas, right? So here, when it is at the stage at here means this due to this fuel, then automatically there will be a change in the resistance of a superconductor wire due to that liquid fuel. It may be in a fluid, cryogenic fluid. What happens means that the resistance of that superconductor wire changes. That will be indicated in the high impedance ohm meter. High impedance ohm meter. High impedance ohm meter. Connected in the high impedance ohm meter. So that is the impedance ohm meter means maybe it impedance is nothing but resistance. The other word of resistance is nothing but impedance. So, in other we can also call as ohm meter. Ohm meter, all of you know that current ohm is here the meter. It is nothing but the name of that meter is high impedance meter. That means that this indicate a resistance. So that resistance is calibrated in terms of the level of the cryogenic fluid in the tank. Otherwise, you know very well about the formula for this resistance of any wire conduct. Already you studied. This is the formula. R is equal to rho L by A. I think all of you know this formula. Rho is nothing but what is rho? A resistivity. Here, rho is nothing but resistivity. R is resistance. L is the length of the conductor wire or superconductor. A is the area. So with the help of this, we can also find out the resistance R. Right. See here, this is another figure, same figure only, right? Superconductor. This is a wire loop. Up to here, we can also call it as this is a wire loop. Up to this, from here to here, we can call it as a superconductor a wire loop. This here up to this point. And with the help of the electrical wires, so that means lead wires, we have to connect to the high impedance ohm meter. And this is the explanation of this one. Uh, so here a gas which changes its state, that is gaseous to liquid, is what I given explanation before. When cooled at a very low temperatures known as cryogenic fluids. Here a cryogenic fluid exists in the liquid state at a very low temperatures only. That means it's a very low temperatures, which are usually less the temperature levels at which the superconductor exhibits zero resistance. Means superconductor exhibits zero resistance characteristics. Sir, with the help of this formula, if you observe clearly, R is equal to rho L by S. Here, R is equal to rho L by S. Here, the length of the superconductor, that is length of the loop, L is equal to R into A by rho. Here, see, with the help of this formula, we can go for calculation of the resistance also, right? There we can, right? This I will end the class, right? So here today, what we discussed today, we discussed three level indicators. What are those? Bubbler level indicator. Here in the bubbler level, when the compressed air ascends, what happens means the dipped end of the bubbler tube, we can get the air bubbles. Then it indicates the pressure of the air is equal to the pressure of the liquid at the bottom. This indicates in the pressure gauge, which is arranged on the bubbler tube, top of the bubbler on the bubbler tube. This is nothing but hydrostatic pressure of a liquid, right? This is proportional to the height of the liquid in a tank. And the next magnetic level indicator. In this is consists of a float, flat. That means flat float. In that a magnetic bar here we are arranging that should be placed in the uh, liquid in a closed chamber. The chamber, sealed chamber, we have, whose level has to be measured. Thereby, what happens means around that chamber, it is a magnetic shielding device, and on that one end, it should be containing a wafers. Here, when the level increases, automatically the wafer color changes. So it indicates the level of the liquid, which is arranged scale at the attached to that indicator, small wafers. So that indicates the level of the liquid in the tank. And here in this cryogenic fuel level indicators, Here it consists of a superconductor wire we have to place into the liquid whose level has to be measured, and that is a loop, superconductor wire loop. So the bottom will touch us on the that is a superconductor wire will touch us to the bottom of the tank, and then here whenever the cryogenic fluid the level increases or decreases automatically, the resistance in the superconductor wire will changes, which indicates on that high impedance ohm meter. This impedance, that is our resistance to the superconductor wire, is calibrated in terms of the level of the cryogenic fluid in the tank. So this is nothing but so the tomorrow we'll discuss about the flow measurement devices. Okay, right. Up to this, I will end the class. Thank you all of you. Right. So better take rest. Now the time is 2:45. Okay, right. 2:43. Great. Thank you to all of you. Here, I will give the attendance. So I will see the attendance. If anybody, there is why, because somebody called me that some of the, especially some of the your friends suffering due to network problem. That means due to these environmental conditions, effects on that network issues. So I will see and that I will give the attendance to you. No need to worry about that. Thank you to all of you.